Hey everybody. Welcome to day 7 of Math 133. Um, it's the end of week 4, so if you haven't uh, attended either the Tuesday or Thursday class, make sure you fill out the discussion board. We've got a lot to cover today. We have cumulative review worksheet number 1, and that's going to cover everything from chapter 1 up through chapter 3. Not all of chapter 1, of course. We have bits and pieces that we've covered, but all of chapter 2, all of chapter 3. We'll have a couple more cumulative review worksheets before the midterm. That'll help you study. Okay. But first, we also have chapter 4, project number 1, um, exploring the correlation coefficient. Okay. Make sure you do your 4.2 and 4.3 lecture notes. Um, and yeah, let's dive in. Um, so the cumulative review worksheet is on page 412, 412 in your course pack. So you want to pull that out. Okay. But we're not going to start there. I want to start with our project today. Okay. So chapter 4, project 1. Here I am in Canvas. Click on that. And there's a video about this assignment, but I want this guy right here. Open the Google document at this link. So I'm going to click on this link, and that brings me here. Okay. We need to go to File, make a copy, so we can edit this. My old project's not used anymore. That's the folder it's in. Okay, well, we're gonna move it to a different folder. So you can put it either in My Drive or you can put it, wherever you like. So make a copy. Okay. All right. So, uh, what we're going to do is right here, we're going to access the applet and StarCrunch. Or sorry, not StarCrunch, StatCrunch. So you'll log into StatCrunch. So if you go to statcrunch.com, or if you click on that link, it'll bring you here. In the upper right, you're going to need to sign in or register. Once you do that, the this button right here, this orange button in the middle, will light up, and that's what we're going to click on. We're going to start with a blank data set today. Okay, so just like this. Okay, so what do we do in the project? So what we're going to do in StatCrunch, statcrunch.com, you're going to select applets, correlation by I, and then click compute. Okay. Um, and that's what we're going to mess around with today. Applets, correlation by I, this one. What did it say? So applets, guess the correlation using an interactive scatter plot. Okay. And then hit compute. Okay. So what this is going to do is it's going to give you a scatter plot. Okay. Scatter plot is an x-axis and a y-axis. Um, and then you have a bunch of dots on here. What this is going to do is, when you have two variables, like if we were looking at the amount of money you make and then compare that to
Oh,
like,
can you
uh,
show how you
oh,
did that again?
oh, sure, absolutely. Um, I went to StatCrunch.com and signed in, and then I went to applets and then correlation by I. Okay, and then I hit compute. So as I was saying, when you are looking at two variables, like let's say on the x-axis, this is how much money you make, and on the y-axis is, I don't know, let's say it's how tall you are. Okay. Are those related to each other? Do you make more money because you're taller? If you are taller, or sorry, if you make more money, does that make you shorter, taller? We usually think that, okay, well, maybe taller people make more, but for the most part, those aren't really correlated. And so you get dots kind of all over the place. Okay. On the other hand, you might have things that are extremely highly correlated, where maybe this right here, the x-axis, this could be, I don't know, how much money you make, and on the y-axis is how much your house costs, how much you spend on housing. Okay. Obviously, the more money you have, the more you'll be able to spend on housing. And so those are going to be much more highly correlated. Um, so when we talk about correlated, we're talking about whether the dots kind of line up or not. Okay. So what this will allow you to do, so under correlation by eye, is you can actually click on any of these dots and you can drag them around like this. I could take this dot here and I can move it all the way over here in the corner. I can move it all the way up here in this corner. And so you can kind of line the dots up if you want, okay? Or not line them up, make them spread out if you like, okay? Um, if you click on reset up here at the top, it'll clear everything. And then we want to have somewhere between like 12 and 15. So if you type sample size 12 in here and hit simulate, it'll give you some new dots, okay? But this is it's kind of a game. What you can do is if you line all these up, really well, kind of like this. If you take your dots and you line them up really well, this is a very highly correlated data set here, like that. And you can kind of guess what your correlation coefficient is going to be, and you would put it in here, and then you can check and you can show what that is, okay? So the correlation coefficient, we're not going to really talk about how to calculate it, but we are going to mess around with what it means and um, when because StatCrunch will calculate it for you. Okay. Um, so let's the correlation coefficient is going to be a number somewhere between -1 and +1. On page 255 is information all about chapter 4. Okay. That's where all this correlation coefficient stuff is coming from, chapter 4. Okay. And there's a really great number line right here that shows you correlation coefficients and what they mean. If you have a correlation coefficient of 1, that means you have your dots in a perfectly straight line. Okay. If you have a correlation coefficient of somewhere between 0.3 and 0.5, that means you have a weak positive correlation. Okay. Um, so that's on page 255. That's in our exam notes packet. But anyway, back here on statcrunch.com, when you go to applets correlation by eye, applets correlation by eye, that'll give you this. Okay. And then hit reset and you put in a sample size of about 12 and then hit simulate. Okay. Now, if we try, let's say we try to line these up in, a line as best we can. Okay. So something like this. All right. So I'm going to put in a guess here of what I think my correlation coefficient is going to be. So it's 0 point something. Give me a guess for what's on my screen. What would be your guess for a correlation coefficient for this? Give me a number between -1 and +1. Andrew says 0. All right, let's try 0. So I'm going to put in a guess of 0 and I'll check. And it says, nope, Try something, try a positive number. Okay. Jenica said negative 0.92. So check that. No, try positive numbers. Try if we try positive 0.92, it says, great, you're within 0.1. You're within 10%. Okay. Um, Chanel's suggesting 3. And the correlation has to be a number between -1 and +1. So it's always going to be a decimal. Okay, so if we did 0.3, check that. Nope, try a bigger number. Okay. Once you have a guess, you can click on show and it'll show you what your correlation is. This is a very high correlation, 0.9956. Okay, so 0.9 is going to land right here in between 0.8 and 1. So 0.9 is like right here, 0.99 is right here. So this is saying that this is a very strong positive correlation. And that's what that would mean is a strong positive correlation means your dots are pretty much lined up. Okay. Um, okay, so let's go back to our project and let's actually start working on this. All right, create a scatter diagram of 12 to 15 observations with a moderate positive relationship. All right, so moderate positive, what number do I need for that? We said that this 0.99 was a strong positive. What number do I need to have a moderate positive? 0.7 sounds good. Yep. So anything between 0.5 and 0.8. Okay. Now that's correlation coefficient. Let's actually talk about what that would look like on my scatter plot. So I'm going to hit reset at the top. Sample size, we'll do 12 again and hit simulate. Okay. So here's my dots. Okay. Now I need a moderate positive. So I need the dots to kind of be in a line but not necessarily like a straight line. Okay. Right now, looking at this, I would guess, you know, having some experience with this, I would guess that I am actually probably close to 0.7, except that if I was to try to draw a line that kind of goes through the middle of these dots, it would be going down. This would be a negative slope. Okay. So this is probably a negative 0.7 correlation. I'm curious. Let me check. Oh no, I'm wrong. Okay. What number is it? Oh, this is a negative 0.91. Okay. So if I move these a little less on the line, how does that look? Yeah, there we go. But that's still pointing down. So I need to try something else. So let's do 12. So basically what I need is I need my line to be pointed upward in order to have a positive correlation. The correlation coefficient has the same sign as your slope. So you can imagine that there's a line going through the middle of these points right here. This is going to have a positive slope, which means it's going to have a positive correlation coefficient. Um, but you don't want your points to be on a straight line, okay? Because we saw a second ago that if you do that, then you get a number very close to 1. We want a number close to like 0.7. Okay. All right. So what we'll do is we'll click on show and we need to kind of move our dots around until we get something close to 0.7-ish. Okay, that looks good. So it's kind of scattered all over the place, but you could still draw a line through the middle. I mean, you'll notice that I don't have any dots up here. Don't have any dots down here. So it's mostly still a line. Okay. Okay. So now that I have that, so Create a scatter diagram of 12 to 15 observations with a moderate positive relationship. Okay, so I've got that. Paste the scatter diagram here, including the correlation coefficient. Okay, so what I'll do is I can use my snipping tool and make sure I include my correlation coefficient, which is the 0.76 down here at the bottom. Okay, and I can copy that over into my project. Okay. Uh, you also can go to options up here and hit copy. And then you'll notice that it does include the correlation coefficient, which I need. I'll right click and copy that image and then paste that into my project. Okay. So there it is. Either of those is fine. So that's question number one here. Next, move some of the observations around to make a weak positive relationship. All right. So what number do I need my correlation coefficient to be for it to be weak? I need a weak positive correlation. So what number am I going after? 0.7 is a moderate positive. You want to make a guess?
You have your yellow sheets to look at.
0.9.
So 0.9 is going to land us right here at strong positive. So if I want a weak positive, I need a number over here. So give me a number between 0.3 and 0.5. 0.4, yep. So that's what I'm going to try to target, okay? You can either start moving your dots around, or you can just hit reset and put in. So we need 12 to 15 points in here. If you do 15, it'll make it a little easier to control. If you do 12, you'll have less dots to move. It doesn't matter. Either way is fine. Um, all right, so what's my correlation coefficient right now? 0.29. So this is actually, my dots are kind of all over the place. So I need to get a little more in line. 0.4. There you go, 0.4. All right. So we kind of need our dots just kind of spread all over the place. Okay. So if you click on showdown here for the correlation, you can see this and you can move your dots around, try to land somewhere between 0.3 and 0.5. Okay. You don't have to be, that close to 0.4. Okay. So you could do like 0.41, whatever, you know. Oh, there we go. So you could do something like that. That's fine. Okay, and then we will paste that in there as well. So grab my snipping tool, make sure I include my correlation at the bottom. I'll put that in here for a weak positive one. Okay. All right. Part C, move some of the observations from the scatter diagram around to make a strong positive relationship. So strong positive would be something like 0.8, 0.9. If you can get a perfectly straight line, you can get 1, 1.0. But you need your dots to kind of line up. So there you go, 0.95, 0.94, so 0.92, okay? Great. So it's not a perfectly straight line, as I said before, but you can definitely see that there is a linear relationship here where the dots in general go from left to right, they go increasing, okay? A second ago when we had the weak positive one, we had dots just kind of all over the place. We had dots over here, dots over here. It was just kind of a mess, right? So, all right. All right, so now that I have this, paste that into my spreadsheet, into my project as well. All right. Part D, if you align all the points into a straight line, perfectly straight line with positive slope, what should be the value of the correlation coefficient? What do you guys think? One, correct. 1.0. That is the highest correlation coefficient that you can get. Okay. So they're not asking for a picture here, and I don't expect you to, because getting 12 to 15 points exactly in a straight line is real hard. Okay. You can do it with 3, and again, you don't need to. This is just, all right. If we wanted this to be a perfectly straight line, how close am I? Close. There it is. Perfectly straight line. Okay. 2, you have 2 points. It's guaranteed to be a straight line. 2 points is always guaranteed to be a straight line. The shortest distance between 2 points is a straight line. You cannot get anything other than 1 or -1. So, but with 3, you can have weird things happen. So like this. So, okay, great. So jumping back over to our project. Not that one. There we go. Question number 2, negative association. Hit the reset at the top. Okay, we can do that. And then create a scatter diagram of 12 to 15 observations with a moderate negative. Moderate negative. So I'll hit reset. And I need like 13, 14 some points. Simulate. Okay. And if I hit show down here, 0.39, that is right here, weak positive. I need moderate negative. So I need over here, I need something that's between negative 0.8 and negative 0.5. Now, negative just means that my line is pointing downward. Okay. So I need my slope to be going from left to right. I need it to be going down. Okay. That's all it means. So start moving my points around. Okay. And you can kind of see I've got a negative line going down this way. Okay. So actually, out over here. Sometimes a dot likes to hide. Like I'll have this all set up and I'll be like, all right, I'm trying to make a strong correlation. I'm like, there's a perfectly straight line. And you're like, how is this a terrible correlation? And I got this dot just hiding down here. So anyway, um, so I'm looking for something between negative 0.5 and negative 0.8. So negative 0.7 is fine. Put it over here. Okay, that looks good. So you can see that I've got a pretty decent correlation with these points, there's a line. You can imagine a line going through the middle of these dots, and all these dots are pretty close to that line, and that line is going down. It's got a negative slope, except I have this outlier guy way over here and this outlier guy way over here that are kind of messing things up a little bit. Okay. If they would just get in line, I'd have a really strong correlation. But I was looking for something between negative 0.8, negative 0.5. So something like negative 0.7 or 0.6. And that's what I have at the moment, 0.63. So this is good. I'm gonna grab a screenshot of this guy. Make sure you include your correlation coefficient there. Put that into our project for the moderate negative. All right. Move some of the observations around to make a weak negative relationship. All right, weak negative. I need something between negative 0.5 and negative 0.3. So if you unclick show and you move your points around, you can actually play the game and try to make a guess what you think your results are going to be. So I still kind of have a line here. It's still negative, but now I've thrown a lot more outliers kind of scattered around. I'm guessing this is at negative 0.4. That's what I'm targeting, 0.4. Oh no, it's not. Okay. I'm still at negative 0.5. I gotta spread my dots out even more. Okay, there we go. That looks better. Negative 0.46. That's good enough. Look on info, lets you know how to play the game. So, okay, that looks good. Need my dots to be a little spread out. Copy that. Weak negative. All right. Strong negative. What correlation coefficient would indicate a strong negative? Yep. Thank you, Andrew. Negative 0.9. So that's what I'm looking for. So uh, let's start putting these in a line, right? Now your line doesn't have to be at a 45-degree angle. I mean, it can be, that's fine. Okay. So here's my line. That is probably a negative 9.5, I would guess. 9.8. Okay. Looks good. Yeah, doing the strong ones is easy. You just you just line them up. The weak ones, you're like, "Ah, you gotta spread them out a lot." All right, there's our strong negative correlation. Okay. Part H, if you line all the points into a straight line with a negative slope, what do you get for the correlation coefficient? Perfectly straight line would be what? Perfect negative. Yep. Perfect negative would be -1. All right. Uh, Part three, no association. Now we're going to create a scatter diagram, 12 to 15 observations with no relationship. So no relationship is this one right here, no linear relationship. So this would be an example of like, uh, let's say you poll a bunch of people and you ask them how many hours they sleep each night, and they put that on the x-axis, and on the y-axis you put how many times they go skiing each year. Those don't have anything to do with each other, right? How many hours you sleep at night and how often you go skiing. I guess maybe you can say like people who don't sleep much, they ski all the time. No, right? Those dots should look like just a hot mess all over the place, right? So if you hit simulate, we'll get a scatter diagram all over the place. And we are looking to get some number between -0.3 and +0.3. I don't care if it's positive or negative, it's just very close to zero. Okay. That's what we're targeting. We're targeting zero this time. So what's our current one? If I hit show, yeah, this is actually good. Okay. But make sure you've got dots up here on the left and on the right and in the bottom and in the top, just all hot mess all over the place. So this looks good. And I will copy this into my project. Okay. Create a scatter diagram with no relationship and post it here. Okay. Create a scatter diagram with a U-shaped pattern. Okay. So like this. Okay. So like a U-shaped pattern. Okay. So this clearly has a pattern, but my correlation coefficient is again close to zero. So that's still telling me that it has no linear relationship. It's not weak or it's not strong or anything. Um, you can have a relationship between your variables. You can have some kind of like U shape or any other shape that you want, as long as if it's not a line, then your correlation coefficient is not going to do well. It's going to be low. It's going to be close to zero. Oh, I got to post. I gotta copy paste my U pattern into my project. There we go. Okay. So dots when you have a hot mess, those can have no relationship close to zero. You can have a very nice pattern and still be close to zero. So, question K, what does a correlation coefficient close to zero suggest? It's not that there's no relationship. Like I said, this U pattern, clearly there is some relationship. There's some kind of formula that you could use to calculate this. Um, but if you have a correlation coefficient close to zero, it just means there is no linear relationship. Okay, that's all that means. Nyla said she just hit X and closed everything. Don't worry, Nyla. So one of the nice things about Google Sheets is, or sorry, Google Documents, is if you go back into this file that you've created, it auto saves. So if I was to close this right now and open it back up, all the stuff that I've pasted is still here. Um, so yeah, you're good. And then for StatCrunch, you just go to applets correlation by eye. So you're fine. And that's why it's important to save these when you do file make a copy, make sure you save it in a location that you'll remember or that you can get to, as opposed to just some random folder. So, all right, part four. Is the correlation coefficient resistant? When we say resistant, we mean is it resistant to outliers? Just like we've talked about mean versus median, and we've talked about if you want to look at your spread, should you use standard deviation or interquartile range? When you have a lot of outliers or something that's skewed, you want to use the median and the interquartile range because they are resistant to outliers. Okay. Well, what about the correlation coefficient? Is it resistant to outliers or not? So in the lower left corner of the applet, draw a scatter diagram of 12 to 15 observations again with a correlation coefficient around 0.8. So 0.8 was right here. It's the border between moderate and strong. So it's a pretty good looking line. It's not a perfectly straight line, but it's pretty good. Um, and then paste it here. Oh, okay, so we're basically just doing another strong correlation. Okay, great. So back over here in StatCrunch, we're gonna reset this and we're gonna do 12 to 14 points. So it's simulate. Oh, it actually put it pretty in a pretty nice looking line for me already. That's good. That's nice. Okay. Um, oh, but I want a 0.8. So it's not, I don't want it to be a perfectly good line. Okay. Um, Draw a scatter diagram with a correlation coefficient around 0.8. Okay, so right now, I'm guessing this is probably 0.9. Yeah, it's 0.9, so I gotta spread these out a little bit. I need a 0.8 here. Okay, what do I got now? 0.9 still. Okay. I mean, you don't have to get to 0.8. 0.89 is fine. 0.7. All right, 0.88. Good enough. All right. So we will grade this one. All right, so we need a correlation coefficient around 0.8. All right, so that's good. 0.88 is fine. All right, part M, add another point in the upper right corner of the applet that roughly lines up with the other points. Okay. So I've got 15 points. If you click on add a point, you can ask where do you want it? So you have to give it a coordinate. So this is the x-axis, the y-axis. So upper right here would be the point 20 comma 20. So that's what I'm going to type in right here. You don't need the parentheses around it, but 20 comma 20. If you okay, it's going to put a dot right here for us. And it lines up with our line, so it actually made our correlation coefficient even better. Okay. Oh, and just and then put a copy of that. So now I've got 16 points. Okay, that's fine. That here. Part N. Move the new point around the scatter diagram and note how the correlation coefficient changes. Explain why the correlation coefficient is not a resistant measure. So I'm going to grab that point at 2020. Really, I mean, you can grab any point. But if I move this guy around, if I move it way over here, look what it does to my correlation coefficient. It just completely destroys it. So if I move it down here, now it's 0.5. Okay. If it's anywhere in this line, I got 0.89, right? But over here, like I'm only moving 1 point and it takes it and from a strong positive and drops it all the way down here, even though I'm only moving 1 point. So uh yeah, definitely correlation coefficient is not resistant to outliers. Okay. If it was resistant to outliers, I would expect it to go from like 0.89 to, I don't know, 0.85, maybe 0.80, but not all the way down to 0.4. That's that's crazy. 0.46 just because I moved that one dot. Um, Uh, correlation coefficient is not resistant to outliers because can change. Um, Correlation coefficient is not resistant to outliers because it can change drastically with even moving a single, not single sense, even moving a single observation around. Observation is just a dot. Moving a single dot around, it can change drastically. So the correlation coefficient is not resistant to outliers because it can change drastically with even moving, when moving even a single observation around. Okay. Okay. Um, Now we've talked about uh, when you have a data set and it's skewed, you should use median and interquartile range, right? Because they're resistant to skewing. Um, there are similar things you can do with least squares regression or linear regression that are resistant to outliers, but they're much less common. Least squares Linear least squares is kind of the standard when you're doing regression. Even though it's not resistant to outliers, you kind of have to just deal with it. Okay. Um, I mean, that's not, and like I said, that's not true. There are other options. Okay. One of the things you can do is you can find not your fences, but something similar where, we've talked about fences in the past. And using those fences, you can say, okay, this is an outlier, and you can throw those outliers out. Okay. But that all said, we're not going to worry too much about that. We just kind of wanted to make sure we understood what the correlation coefficient means and how it is affected by things. Okay. That is the end of the project. So we're going to go up here to share in the upper right and make sure we change this from restricted to anyone with the link. And then we're going to click on the copy link and it'll say link copied. We're going to come back over here to Canvas chapter 4, project 1, web URL, and we will paste that in here and hit submit assignment, get our confetti, and that's project 1. That's our chapter 4 project. Okay. All right. Excellent. Okay. So staying here in Canvas, because that's all. So we do have another thing to work on today. Back in Canvas here, we are also going to work on the cumulative review worksheet, which is chapters 1 through 3. You'll find that in your course pack on page 412, 412. And also, if you click in Canvas on that's the project. I didn't want to click on the project. I wanted to click on the cumulative review. So under day 7, cumulative review worksheet number 1, if you click on that, there is a link to the data sets right here at this link. Now, this is the sheet that we've seen before. Make sure you click on the right one. We are looking at the cumulative review worksheet, which is down here, cumulative review number 1. There is a Google Sheet to click on, and there is also a StatCrunch to click on. Hopefully, since you're signed in, it'll stay signed in, but if you need to, you can sign in. But this is going to have some of the data sets already in the that are in the cumulative review here for us, so we don't have to go and find them, okay, or print them out or anything. So, okay, where do I want to go? I want to go here. All right, so page 412. Now, uh, I'm going to give you some hints on some of the ones that I think are pretty difficult, and then we'll stop the recording. We'll get as far as we can in this worksheet today. Okay. Let me see. Let me actually, I want to go back to Canvas for a second. Uh, by the way, um, this review worksheet. Da, da, da. Okay. Um, Chapter 4, Project 1 is due September 23rd, which is Tuesday. Now we just did it, so and we've already turned it in. But if you need a little bit more time, you need to go back and rewatch the recording or anything like that, that's fine. It's due September 23rd on Tuesday. The cumulative review worksheet, I'm assigning it today, and we're going to get as far as we can, but it is not due on Tuesday. It is due on Thursday, September 25th. Okay. We'll try to get as much done today as we can, and anything that we miss, we'll try to cover next Tuesday. But you have a little bit of time. I actually put a note in here for next Tuesday. Don't forget to finish cumulative review worksheet number 1. But yeah, that's next time. So, okay, so page 412, 412. Okay. So we have at the start the following graph shows the incarceration rates of all countries and territories in the world. So which type of graph is this? What type of graph is this, guys? It is a histogram. Yep. Now, is it a frequency histogram or a relative frequency histogram? It is frequency. Thank you, Andrew. And I know that because the height of my bars are measuring whole numbers. Frequencies are counts. So this is saying there are 24 countries that have an incarceration rate between 0 and 50. Well, actually 49.9, but whatever. There's 24 countries in this bar. There's one country that has an incarceration rate up here. Okay. If my bars had been measuring percentages or proportions or decimals, okay, then that would be a relative frequency histogram. Okay. By the way, frequency polygon is very similar to the frequency histogram. It's just that you would be connecting the bars up and it makes some kind of shape like this. Okay. You can't really see it, but that's what a frequency polygon would look like. I'm going to skip some of the ones that I think you guys can handle on your own. This one here, part F, this one you'll find on page 253, which is in your exam notes packet. Page 253 at the bottom, there is a script for interpreting the percentiles. Okay, so you can use that. Remember, when we say interpret, okay, we mean we want a sentence. Okay, and this is what the sentence should look like. On the next page, page 413, we have another frequency distribution. We've seen these before. We've looked at these and where we fill in the midpoints and the relative frequencies, cumulative frequencies, and so on. That is the Google sheet that I had you click on, right? So cumulative review number 1, this Google sheet right here has all of those numbers in here. So you don't need to submit this as a project, but you do need to fill in the numbers on the paper here. Okay. Okay, so once you've done all of that, skewed left, skewed right. Okay, that all sounds good. Um, yeah, this one right here, find the mean and the standard deviation. Okay. For that, we have 3 methods for calculating standard deviation. And this one, since we have a frequency distribution, is method 2 on page 254. Okay. And then don't forget to interpret what that means. And that interpretation is that give or take script. Okay. The give or take script on page 253. On page 414, the following data shows the average age at marriage for men in a random sample of states. Okay. Um, and this one, we want to find our mean and standard deviation and more stuff, right? Variance, median. So page 254, method one, because we have just the raw data. This is not a frequency distribution. This is just a column of numbers. Okay. Interpret, right? Interpret, that's on the bottom of page 253. It's that same script for that you're going to use for question number one. Okay. In Utah, the average age at marriage for men is 26 years old. What is Utah's Z-score? So on page 253, Z-score is equal to your X value minus your mean divided by your standard deviation. Okay. If you're going to type that into Desmos, you need parentheses around the top and bottom. That's going to give you your Z-score. Now, your Z-score is, it can be positive, it can be negative. It does not have to be between -1 and +1. Okay. It can be -2, -8, whatever. Okay. Is it unusual? So we have two ways that we look at unusual, and that's on page 253. Something is considered unusual if the z-score is beyond two standard deviations from the mean. Something is considered unusual if the probability is less than 5%. So it's important when you're talking about if something's unusual, is the number that you have a z value or a probability? Okay. And those are interchangeable, but they're not always the same. So, right, um, this is the z-axis here, and it's measuring how many standard deviations that number is away from the average. Okay. That's what deviation means. It's how far is that number away from the mean? How far is it deviated away from the normal average middle number? Okay. On the other hand, though, every z value, every standard deviation corresponds to a probability. Okay. And so basically, this is where we get that unusual definition is 95% of your data is going to be between -2 and +2 standard deviations. Okay. So that's why we talk about two standard deviations and we talk about 5%, right? 95% is usual, the other 5% is unusual. All right. Um, the wheelbase of all cars built in 2019 was normally distributed with mu, which is a mean of 110 inches, and sigma, which is a standard deviation of 7.3. So we need to fill this guy in using the chart on page 253. So you're going to make sure you draw your lines here. Your middle number is your mean, which in this case is 110.2. And then you subtract your standard deviation and you add your standard deviation. Put in your percents here. Okay. 34. Okay. So you fill all that out. Okay. I think that's all the hints that I'm going to give. Um, again, this is not due on Tuesday. It's due a week from today. So you have some time to work on it. And this is a good sheet to use to study for the midterm because it covers chapter 2 and chapter 3. Um, but I gave you some hints so you know how we calculated that. You can look up because just seeing like okay, watching me do the assignment and get all the right answers is not necessarily the best way to study for test day. um, Best way to study for test day is go back over the work that we've done and figure out if you can do it yourself or if you have questions. And so that's one of the reasons why I give you hints on where to find how we actually did that and how did we get that answer, right? So okay. So I'm gonna stop the recording and we'll fill in as much as we can today. Okay.